Namaste Javins, myself Javin Dr. Barkha Khurana. Today in biomechanics, I will be telling you about ground reaction forces, and apart from that, we will also be discussing about momentum. See, the ground reaction forces, these are measured during gait. Gait is the pattern of walking, and whenever the foot is in contact with the floor or the ground, this is analyzed. So it can be seen while walking, running, all these stages that we will be studying. We will be studying about ground reaction forces in this. We can say magnitude of the vertical component of the GRF during running is generally 2 to 3 times the runner's body weight. Now the runners are classified as rear foot, mid foot or forefoot strikers. Now this ground reaction force is the external force that is acting on a human body, and its magnitude and directions have implications over the performance in many sporting events like baseball pitching, golf and all. Now what momentum is? Momentum is a vector quantity having both direction and magnitude. It is a quantity of motion that an object possesses, and it is the mechanical quantity important in collisions. Then we have linear momentum, which is the product of an object's mass and its velocity. If the body has zero velocity, obviously there will be no momentum. Next is impulse, which is the product of force and the time interval over which the force acts. And impulse can change the momentum also. Now if we take these two together, that is impulse and momentum, changes in momentum depend not only on the magnitude of the acting external forces, but also on the length of the time over which each force acts. And when impulse acts on a system, the result is a change in the system's total momentum. So impulse can change the total momentum of an object or of a body. Next is angular momentum. Here we can say the quantity of angular motion possessed by a body measured as a product of moment of inertia and angular velocity. So it is denoted as h, and h is a product of angular inertial property, that is moment of inertia, and angular velocity. Next is linear momentum, which is the product of linear inertial property, mass, and linear velocity. Here you can see these formulas. Mass, distribution of that mass with respect to axis of rotation, and angular velocity of the body can affect the magnitude of a body's angular momentum. If a body has no angular momentum, that means there won't be any angular velocity, that means there will be no angular momentum also. Mass or angular velocity increases, and thus angular momentum increases proportionally. Now, what is the importance of all these things in biomechanics? We cover all these topics to understand the human movement in relation to forces that are acting on the body, the joint, the muscles, and how the motion takes place. So this is all in this session. I hope you understood this session well. If you have any doubts, you can post a comment. This session is powered by Digital 2.0, Jyoti Vidyapeeth Women University. Thank you.